There we go. Sorry. Let's see. We ended the last stream. Um, like what we're used to with state management in React is that we don't really have any concept of doing like nested stores like we do controllers in other solutions. So I was a big fan of AngularJS when it came out. Like it was a huge deal. One thing was kind of this magic. It's kind of weird. I was never exposed to Knockout JS, so I think a lot of people, well, people who were exposed to Knockout JS, they already had this moment, but I never tried that. So for me, it was like going from Backbone JS to Angular JS. The only problem with Angular JS is that it was super slow. And it had a lot of magic to it to achieve what it achieved, but it had some fundamental, really good ideas. One of them being having this controller, and you could like go into any part of your like HTML, and you can just say ng controller. You got the controller, and these controllers, they were connected through a scope. And it's funny how similar impact really is, because instead of having controllers, you have stores. Instead of having a scope, you have this store container that knows about the parent store and parent store and parent store. Now, the point is that these stores, they expose a public API to the components. And there's certain things you don't necessarily want. So unless a store can consume a parent store, but it will consume its public API, right? And you might not want to do that. You might want to communicate with a private part of the parent store, because anything's public can be consumed by a component. Anyways, the way AngularJS does this is that it has events. So you can emit events up the scope, which hits controllers, parent controllers. You can even broadcast down. I don't quite understand why that's really needed. And I don't think it's needed here because React reconciles and you pass props and stuff. But the point is you need to receive these events at some parent store. And with AngularJS, there was no TypeScript and stuff like that. And there is this abstraction over events called RPC that makes a lot of sense here, because what you can do is that you can define these events as methods that can take params and they can even return something. So it's like calling a method, but it's event-based. And then what you can do in a store, you can say that this store is a receiver of my store events, and then you define these methods and you handle it. So whenever this method is like called, you handle it. And then in any nested store, you can create an emitter of the same events. And then you can say emit.foo in this case. And then that will hit this method up here. And this is like, the reason this is necessary is because we have these decoupled nested stores. And again, you don't have to do this. Like, and this is the thing, like there's a lot of stuff you can get away with being a single developer, even managing a lot of complexity. You can get away with, like, we're talking about changing state. You could expose like all the signals as is in components. You can change them from any component. You can do whatever you want, and you'll get away with that as a single developer. The challenge is when you become a larger team, and there's no like boundaries. But at the same time, I'm really hesitant adding any new API. But again, it's very much an addition. It's something you don't have to do. Oh my god. And it's very simple, implementation wise. So I want to try to implement it just to see how it feels, and then yeah, let's try it. Let's implement it. Just 2 seconds. Sorry. Okay. So what we need to do, let's shove this into a branch. Let's do this later. Git pull events. By the way, I want to see if does it work now? Yeah, now it works. Nice. Let's see. Does all the learning things work? I guess we go from store. That one works. Nested store. Signals. Blah blah. Derived. Effects. Nice. Promises. Nice. Okay. Does this thing work? List. Oh, what did I do here? You cannot use React hooks inside stores. Why does it say that? Items. What did I do? Using use observer. Why does it say I'm using a React? Oh, wait a minute. Oh, that's interesting. Oh. Yeah, of course. Okay, let's fix that quickly first. Oh, this is weird. Because I'm using the, like, we have this ability to throw an error if you're using React hooks inside stores. But that should only be active during the instantiation of this store. Just have a feeling it's It's coming from use observer. So use store is the thing that's blocking. Let's see, blockable dispatcher. I didn't test this very well, did I? So if we're not currently resolving something, we're resolving from component. But we are unblocking immediately. And this is also item store provider. I wonder what's happening there. Because we're resolving the store, then we're unblocking the dispatcher. This is synchronous. Maybe I did something wrong in implementation. Dispatcher and blocker. Oh, this is definitely wrong. This should be is blocking true. Like this should always be true. Why aren't? Oh, that's interesting. They should always be set to true, but then it should be set back to false as soon as this is called. So it doesn't make any sense regardless. I find that very weird because it's calling on use observe. That's also weird. Like this is the first time. This is the first time it's being called. So use observer. Like this doesn't do anything. Yeah, and throws immediately. So it's block dispatcher. Well, this should be false. Oh, maybe that's the problem. Oh, I think that's the problem. It's blocking it. Well, it needs to be called. I found this to be weird. I need to look into that. Let's copy this. Ah, god damn it. We were gonna implement something. I'm gonna take this and shove it into development here. Let's just put it in here. Oh. Why are we getting all these errors? Okay. Why is it saying this? Is it just because? Yeah, I have no idea what that is. Doesn't matter. So I guess we shouldn't have the same error here. We can figure out what the hell is going on. Oh my god. Unsupported server component. Oh, and I guess this should be export export function counter, since it was the counter. Yeah, there we have it. Okay, so let's see what the hell is going on here. So what if we're just gonna return null here? Does it still? Yeah. It's almost like, this is so weird. It's the first time. Okay, if we don't do this, then of course it works. Oops. Yeah. But as soon as we do use store, You cannot use React hooks inside stores. So let's take a look at use store. So it should hit this one. Whoop. Oh, interesting. Oh, it doesn't think it's development. It thinks it's production. But that can't be it, because then it wouldn't block. What the hell? I'm super confused. Where the hell is block dispatcher being called from? Oh, is it actually? Okay, this makes me super confused. Ha! How how is this possible? The only way it can go and do that is when it's because I am oops. I don't understand this. Why isn't that log running? Um It doesn't seem to be using the local one. Impact, development impact, next. This is impact react dist ESM. Goddamn webpack. I hope next changes to Vite. There's no reason to use webpack. This is very confusing. Is it using the local one? Yarn build. Why isn't it showing any console logs? Oh, for fuck's sake. What the fuck is going on? There's the console log. Why isn't it showing? Is it coming from... Oh, wait a minute. It probably is here. Fucking next server side. Oh, whatever. Okay, I think it's because it's just running on the server, so I can't see the log here. Well, this is a lot of... Come on. So what's happening? Page Is there any console log here? Why aren't there so many errors? There we go. What the fuck? Whoop, blocking dispatcher. And then immediately you cannot use React hooks inside the stores. Okay, at least we have something here. So, whoop. So we did do it here, and then container.resolve, like this happens synchronously. So when we call unblock dispatcher, everything should be fine. Because unblock, how can this be true? Okay, let's just log unblocking. Oh, props.items is not iterable. Oh, this is interesting. Oh, so it isn't. Oh my god. I see what's happening. So there might. Okay. I know what's wrong. This is fine. It's just over. Let's see. It's not a biggie. Block. We have to try this. We have to do it like this because there's just an error resolving the store. I'm using a wrong. There's a wrong code somewhere. Yeah, I'm using props.items instead of initial items. And then we're not unblocking the dispatcher, so now you get a different error. So it's kind of swallowing the original error. So now it will run this before it throws the error, I believe. Something we can check. Try. Finally. Let's see. Yeah. Now I get the original error. So this is just me messing up the example. So this was the list, wasn't it? Well, let's see what's wrong here first. So this is basically just, this should be items, I think. There we go. Okay, so it was a simple thing, but nice to pick that up. And we can just keep this as part of the implementation or what we're gonna do now. But we can fix the actual docs. What was it? Deep dive lists. Let's call it items here instead. There we go. Cool. Let's go and actually implement the thing we're supposed to implement. Sorry, I have to excuse my nose. So there's two aspects of this. It's the receiver and the emitter. And the receiver is the simplest one. Oh, are we not using this anymore? We're gonna be using this, so we'll keep it for now. Is server. Yeah, because there was something about next use sync external store. I don't think this is true anymore though. But we can keep it. Yeah, if server, oops, return symbol. No reason to set up a context of server context on the server. Okay, anyways, now let's get to it. Active. Oh yeah, now we don't need this one anymore. Nice. Let's put this at the end. So that would be, there's two functions: export function receiver, export function emitter. And what we're gonna do, we're gonna look at the store container, and we're gonna give it should we just make that public? Yeah, let's do that. Events, that's just an object. The events register with receiver. The RPC events register with receiver. Oh, there's one problem. If it's a global store. Ah, damn it. Okay. That kind of ruined it. Because now we can fix it. Resolve global store. So we have global stores. Currently global stores is the actual store reference, and then I'm saying any here, but this should be the instance, and we could have the events there. What is kind of tricky is so one global store can use another global store, but they don't resolve into each other. Like it's just a flat tree of dependencies. So it doesn't have this like hierarchy. Maybe I have to think more about this. So we could just add the events here. And if we don't find a parent store container matching the event, we could look through the global stores. And if a global store would for some reason emit an event, we would just check to see if one of the other global stores matches that event. But this is kind of why I've been thinking about like not having global stores. Because one thing is using the React context to make these nested stores. Like, it doesn't really make sense to have multiple global stores. That's my point. You can just put everything in one single store. Like, I never really asked myself that question. Like, why would you want to have multiple global stores? Because you can just compose together logic into like a single. But then it's kind of annoying because you want to make things approachable. So for example here, I don't really want to bring in complexity. It should be as simple as possible. But maybe you do want multiple global stores. I don't know. Oh. But yeah, it's just that these events are based on hierarchy. You have a receiver that needs to be higher up than the emitter. But now with global stores, that does not really make sense. We could throw an error. We could like make global stores receivers, but they can't be emitters. Like, because it's about what's natural, and it's really not natural to emit something from one global store to another. If they are so dependent on each other, you just put them in the same store. So we could say that. But that doesn't change the fact that they need to be able to add store any events. Where's the result global stores? So this would be store, and events will be like this. Oh. Oh, but this is interesting. No, this isn't as easy as I thought, because you want to create yeah, no, it isn't that bad. The point is that receiver would be called during this execution. So we need to have a global placeholder for any receiver calls. I'm just thinking about who's responsible for last resolved events. Okay, let's just keep that there for now. And then we have, oh yeah, resolve global store. Why is this complaining? It's possibly undefined. How can it be possibly undefined? Oh, is this a goddamn TypeScript? Why does it say that? Why does it say that can still be undefined? That's not true. Because I'm saying if no result store, we are setting it. But maybe it's because I do ts ignore. Oh my god, it's so annoying. I thought TypeScript was smart enough to understand this. Okay, I'm getting crazy demotivated there. God damn it. Is it because of this thing? No. Why the hell do you think it can be undefined here? It can't be undefined here because I'm setting it here. Oh my god. Whatever. TS ignore the fuck out of this. Cool. And then I wonder store container. Because store container says yeah, so that would be when we actually, let's see, resolve. Where is it? When we actually resolve. So this is where we are creating the store. Yeah, and then we would have to, yeah, basically here, we would have to kind of hmm. Last result, any. We use a global reference to the resolved events of a receiver as to global store or the store container. Could maybe do that a little bit differently, but doesn't matter. So when we resolve, where is it? Resolve global when we resolve a global store, we want to say last resolved events is empty. And that's fine. We don't really need to remove it again. It doesn't matter. I guess. Yeah, so events can be undefined. Let's just do that. So after we resolve a store, we say, or after we actually assign the last resolved event, which could be undefined, we make it undefined. And then for the store container, we also say events, and we just say any, I don't care. And when we resolve, let's see. When we resolve, what we would do here we call the store constructor. So that means this does events equals last resolved events, and then we say last resolved events is undefined. We have to comment this though. We have called the store. I've called the store, and events might have been registered with receiver. Yeah. So what we need to, it's very simple really what we need to do. So receiver takes which needs to be like a record of methods really, extends method string or event, let's just call it event string, and this needs to be like a function params any, return any. That's the signature of an event. Let's just call it event method, event RPC or something. So what you get in here are events, which is a T, and if no resolving is resolving. Did we have resolving? Didn't I have like a current? Was it current? No, I thought I had like a resolving store containers. Didn't I like check? Yeah, get resolving store containers, sorry. If no get resolving store container, throw new error, cannot call receive receiver outside a store. Yeah, let's just call it that. And last resolved events is now the events. This is all we do in the receiver. And then when the store is instantiated, we add those last resolved events either to the global thingy or to the store container. And then it's put to undefined, so it's ready for the next thing. And then the emitter takes, extends event RPC, and it's actually gonna return that instead. So it's not gonna take any arguments. We're just gonna create an emitter of these things. And then again, if we're not resolving, can I call emitter outside the store? And what we're basically going to return here is a proxy. And then we're going to use that proxy to find wait a minute, how are we going to do this? Oh, yeah. So let's store container equals get result. If no store container, we throw the error. And then we're going to return a new proxy here. And basically what this proxy is going to do is, how does this work? Get, and let's do as t. So this is going to take like a prop. I think this is the key. And this will kind of be the event. What did I do here? Okay, this is the event. And then we're going to return the actual function. So now we have the event name. And here we get the actual params. And then what we're going to do is we're going to go and find this thing. We're going to go and find the so while so const current store container event. And then we're gonna do while current store container, we're gonna check if current store container, aren't we getting any types here? Oh, instance of store container and current events. Does it have the event? Let's see. Oh, what's happening here? Is it a dot there? Okay, what the hell is this? Oh, target. That's target. Let's do this. So what we're doing is that we're checking if it has that event, and if it does, we're gonna say return current store container event, call it with the params. Now we're just calling that function, and then else if current store container, and now it's a global one, right? Why aren't you understanding? Oh. Okay, so because it can still be a store container. So we need to do this else. So okay, so if it is still a store container, else if and okay, this is interesting. Don't I have access to the parent? Where's the parent? Oh, there it is. Private. Let's not make that. Let's say public parent instead. Hi, Adam. Let's see. and we have a parent, we're gonna say current store container equals current store container parent, and then we're gonna continue. This is gonna be a hefty list of. I'm gonna write this differently. It's a little bit horrible. I think I'm gonna just separate them. So if it's a store container and we find an event there, let's just call the event with the params and return it. If it's a store container and it has a parent, let's change the current store container to that parent and continue evaluating. And then we have if current, does it understand it now? No, because it can still be a store container. But it doesn't have a parent. So if it's still a store container, we're gonna go through the global ones and see if we can find oh, you know what we can do? So the point is, if the current store container is global, oh, that, okay, this is interesting. Store container. Oh. Yeah. So if store container instance of, if not instance of store container, only error, cannot call emitter. So now these should always be store container. Okay, nice. Nice. So if we have the event, do it. If we have a parent, do it. And or we're gonna try to find it in the global ones, which means we have to go through them, global stores for each. Oh, is a map. I think we can do values, and this is like array. This is like an iterable iterator. And then we can say events by saying array from global stores values. Can't I do that? Why is it? I thought I could do that. Oh, do I need to call it? Yeah, you have to call it. Find. Let's see, and this is, oh my god, event in global store. Well, boolean global store events event. Oh my god, just implementing it. And then if no events, throw new error, there are no receivers for the event plus event. And then we'll do the same. Events, event, params. Cool. I think that's it. That is the implementation. It's still a question if it's a good idea. So if you're here, Adam, I'm working on Like we briefly talked about this. Like a good thing about having a single global store and doing like classes, for example, nested classes, is that when you construct that nested class or that nested store, you can give it private references. So you can say that this app store creates a grocery store. And when it creates that grocery store, it can give it, for example, a callback to make some changes in the app store. And that callback is never exposed to the components, the UI layer. It's just a contract between the app store and the grocery store. And we don't have that when you do have these decoupled nested stores. There's no behind the scenes interaction between the stores. And I remember from AngularJS, they had kind of like we have store container. They have something called scope. And on that scope, you could emit events and listen to events. So you could have a controller, parent controller could listen to events, and you could have a child controller emitting an event. And then the parent controller will be able to handle that event. The thing is that events aren't very nice, but RPC is very nice. So basically, it sounds very complicated, but it should feel pretty nice in terms of implementation, like actually, or the developer experience. So the way this would work, so this I can still do impact React there. Let's try to create an example here. So we have to export a counter here. Why are you complaining? Oh, come on. Was it able to? Of course, it wasn't able to build it. 990. Let's try again. Noise, and then there we go. So we have to set up this structure. Let's just do the example. So we have like an app store. That app store has some groceries. Let's just do a string. And then it exposes those groceries to the components like so. But then we have this grocery store. And this grocery store takes groceries as a prop. Yeah, scope, that thing. So what happens here is that it gets groceries as a prop, but the props, which is a change I just made, Adam, is props are read-only. Like just like props from a component are read-only, props coming into a store is also read-only. Like they are signals under the hood. So when you access like props.groceries in this case, you are accessing the signal representing that prop. But it's like a getter, just like when you expose state from a store, you expose it with getters, so they are like read-only. So components can't just change them. It's the same thing here. But the question is like, what if I want grocery stores to be able to add a grocery to this higher up, like this might be some data fetching, like pre-fetching the groceries or something, and they need to be available to a lot of different parts of the applications. I want it to be in this upper store, but then I have this nested store that is actually managing the groceries, allowing you to add the grocery. And let's build up like the actual. So we have app here. So app is kind of like, let's do use observer. Let's just and we're gonna make a grocery store provider, create groceries. Oh, create store provider, grocery store. Yeah, sorry, return. And it's basically just what we're gonna do here is just mount this thing, and we're gonna pass it some groceries, and that's coming from const app store, use store, app store. This seems a little bit weird, but yeah, and then we need groceries. Like, it's such a weird example, but that's the thing about what are you complaining about? Oh, I think this is just it's just some React typing issue. I have no idea. It's because I'm using Next, and I think I have like a different version. Let's see if I can fix it here. I think I just need to yarn install. I had React 19, but Next is forced to be React 18, and then yeah, here we go. No, it's fine. Anyways, so the point is that we have this let's just do app. we have this app store which manages the groceries because they're spread around in all parts of the UI. We want to prefetch them and all of that stuff. And then it wants to expose that to the components so it can be used by any component. And that's what we're doing here in the app, is that we're grabbing these groceries, but then we're passing them into the groceries store provider. But we want to keep it locked down, right? This is the public API of the App Store, and you can only read the groceries from there. You can't change them. But then we have this groceries store, which manages the state of putting stuff into the groceries list. And we wanted to be able to actually add something to this groceries thing. But since we only have this public API, it means that if I want this grocery store to be able to add something, it means that any component can also add something. So the idea is that you can define a type like app store events, and then you can say add grocery string, and it doesn't return anything. And then you can say receiver, and you have add grocery, and then you can say groceries current, and then grocery. So now we just say that any nested store is allowed to call this add grocery to add groceries. And then inside here, we're gonna do something similar. Let's say add grocery. And the thing is, like, in this example, we can very easily argue that we could just add that to the App Store, the add grocery thing. But then there's other stuff that happens. It's not just adding the grocery. It's doing like, it's actually calling the API to save the new grocery. It might do other state management related to that groceries list. So what I see would happen is that you will kind of blow up this app store just because it's responsible for preloading and like just having the data here. It doesn't need to have all the logic for that data. So what you would do here is you would say emit, and then you say emitter. And this would use the same App Store events. Oh, is that wrong? Why doesn't it satisfy? Oh, did I make a mistake? Emitter. Oh, sorry. Event string. There we go. My bad. Do I have to build it? Yarn build. So now you're able to emit. Sorry. Add grocery. So you can send that up the chain and it will be added. And then we say get groceries. So the point is, looking at this, is that we should be able to, wonder how this is going to look like. Grocery store, use store. Grocery store. Yeah, and here we can just grab the groceries and add grocery. Let's just do a quick UI on this. Input. Oh my god. Can I just do on key down? Const grocery, set grocery, use state. Can't I use state here? Seriously? Why is it? That's weird. Input value, grocery. On change, event, set grocery, event target value. And then on key down, event. If event key, is it key equals enter or something? And grocery. Let's just set grocery, nothing. And then we'll have a list of groceries, map. Grocery, li, grocery, key, grocery, given, well, it should be index, I guess. Index. Okay, something like that. So the data flow here. So this is a thing, like creating this bridge between React and Impact and kind of taking advantage of doing this nesting. It doesn't, like, at some abstraction level, it's like way more complex, right? Because you don't have this separate world over here where you only work in that world, and then you have React over here just consuming state from that other world. Now data can flow. Here you have a groceries list that's being consumed by React here in the app, and then those groceries are passed into the grocery store again, and then the grocery store is exposing those groceries again down here. So it's like it's coming from Impact into React, back into a store, and out to React again. And that is complicated. Like, but I I don't think it necessarily feels like, because it's technically doing that, but I'm not sure if at the level of thinking and abstraction when you actually work with this that you think about it. Or I guess that's what I'm reflecting on. Like, in some sense, you're simplifying something, but it's also making things, I don't know, is it any easier in other tools? Like, this is complex. Like, you have a source of data somewhere, and then you want to adhere to these principles of public versus private. Like, it is a natural flow. You could also argue that there's no reason to pass the groceries in here. Like, it's more of a convenience thing. We're just exposing the groceries. You could still just grab the groceries from the app store and just drop passing them as props and just have this emitter to like being able to add them. That would be just fine. But it's nice to have it. Yeah, so we're just re-exposing the groceries. Anyways, just reflecting, thinking. But the point is, what I wonder, I'm so deep in the technical implementation of this. I wonder how natural it feels. Like when someone's like on the website, we state nested stores. Yeah, that makes a lot of sense. But what does it mean for props passing? What does it mean for public API of stores versus communicating behind the scenes of stores? Like, there's stuff, the broad concept makes a shit ton of sense, but then there are like these intricacies that you don't think about but needs to be managed somehow. But yeah, anyways, this should kind of just work now, I think. Do we have it running? No, I think I stopped it. Yarn dev. Bum 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 bum. Was there any errors? Hello. What's happening here? Oh, here it is. Wait a minute. What's happening here? Reading, can read properties of undefined. Oh, counter. Oh, sorry. But shouldn't this throw the error? Like the... No, wait. What is this? App Store.groceries. Why is it saying that? What did I break? Why is it saying that? What is this what the fuck thing? Oh. What the fuck? We don't need that one. But I wonder why it says, what is App Store? Console.log. Oh, I think I know what it is. It was because of these events things. I did not properly extract the... Yeah. Wait. What? Grosh. Okay, that makes me very confused. Cannot read properties of undefined. Reading. What the hell? When I log it, it has the groceries there. What did I do? And now it's suddenly here. But when I log the App Store, it has it. What the hell did I do? Use store. So it goes here. It's not production. Resolve global store. Oh, sorry. Now I see what I did. This is result store. Oh my god. That's reading map. Okay, cool. So yeah, sorry about that. What? Wait, now I did something weird. What did I do? I misinterpreted the. Why is this? Yeah, I'm not sure why this is so angry. It doesn't make any sense. Why is it? It says it can be undefined. Why suddenly can it be undefined? That's a mystery to me. No, it has to be there now. What the hell? Why does it suddenly do this now? I don't understand that. And why is this? Why does... Okay, there's something I'm doing wrong. Oh, wait a minute. Oh, of course, I'm mixing up things here. So resolved store is... So here we're gonna say, oh, okay, I'm mixing up because now resolved store is not resolved store. It's global store. So let's say if no global store, and then we're gonna say, yeah, of course, resolved store like that, and then we're gonna say, sorry about this. Of course, this was completely messed up. Global store. Oh, sorry. Global store. Blah blah blah. There we go. Now it should be more happy. Oh, this should be a global store. Dot store. There we go. Now you're happy. Okay. I can't type anything here now. Is there an... Oh. God damn it. Input style color black. Can't believe this. So hello. Oh, is it enter? Or is it enter? Of course it is. Hello. Oh, something happened. Cool. So there's something wrong with my implementation. That's not a huge thing. Okay, so it says that this, for some reason, that this isn't an actual function, which I find peculiar. Let's see what I did. So what the hell is this events thing? Oh, it didn't give me the actual events. Oh, sorry. Yeah. My bad. Because here we have the events. Yeah. So find. Yeah, exactly. Events. That's what we need to do. So hello. And there we have it. Okay, let's review. So the point is, like, the example again doesn't show the real complexity, but the complexity is I have a store that I want to take care of, for example, the groceries, all the actual source of the groceries. And then I want to expose that to any part of the application, so I do that. But then it should also be possible to add groceries to this list optimistically. But I don't want that to be the responsibility of this store. The responsibility of this store is just to fetch the initial groceries and hold them, maybe even subscribe to them if there's a general grocery subscription to that data. That's the responsibility of the App Store. And then there is this other store that's responsible for the actual groceries list. And that's the one that actually had all this logic of like adding and filtering groceries and do all the complexity around grocery shopping. And as part of that, I wanted to be able to add a grocery. But it can't be added in isolation. It needs to be added to the actual source of the groceries where the data is. So, but I don't want any component to do that. That's between the state management layer. So what I do to handle that is that I make the App Store exposes an API to any nested store, in this case add grocery, and it will just update those groceries. And then in this nested store, we emit these events, or we create an emitter, sorry, based on the App Store events, and then we just emit adding a grocery. And then there's like conceptually, under the hood, it is kind of like events, but it's called, the real name for this is RPC. But at the same time, I don't think RPC really has strict terminology for the receiver and the emitter. While developers knows like events, it has an emitter, it has a receiver. So another thing is like the wording here. But I think this does make sense. And you don't have to use it. That's the point. You can use it. And this is basically scope. Yeah. Just so I don't forget, I'm just gonna add version here. It needs to be documented and everything, but at least we implemented it. We can sit with it for a while, But the way I intend to introduce it in like the docs, I won't even mention it in the learning section. It will be a part of, so one deep dive I want to write is how you actually manage complexity of, so when you think about state management in terms of values, you have like booleans and numbers, and then you might have lists, but it might just be strings. Or you might have some complex objects. And this is, if you're still here, Adam, these are the objects that you talked about. You had this massive table, and you want to granularly update the properties or consume the properties of these objects for each row in the table and all of this stuff. So that means that in object-oriented world, you would create a class as like the container. But here you just really create an object, but you can like close over that object to create signals and all of this stuff. And you can have an API. Like the thing is, like there's two ways to define a class. You have username Joe. And then you instantiate that user A by saying new user. But there is a different way of doing it, and that is to say function create user return username Joe, and then user B is create user. So if you wanted to make this a signal, you would say signal Joe, for example. But the problem with doing this is not, now this is a signal. You can get it, you can set it, you can do whatever you want with it. If you wanted this signal to only be exposed as like a read only, you should only access it internally. You would have to do like this and then get username, return this username, like that, for example. But here you basically do the same. You say username Joe and then get username, return username. Oh, so my point is that all the stuff you can do in a class, you can do with just a plain function instead. And you don't have to have this return, have this reference. You don't need this special thing. It's especially private. Like it's not private, it's like private. There's additional syntax to a class that you avoid by just using a function and returning an object. Anyways, my point is that now you have created, just like you created this user instance isn't observable in and of itself. It's a static object that has nothing to do with reconciliation in React or anything. It's just, it has the same, this user has the same reference regardless of how much the username updates. But that's true for this one as well. We're returning an object which has an observable property. So the object instance of this user will never change. So that means if you pass user A here or user B to a child component, if you use memo on that child component, it will never reconcile because the actual reference to the user will always be the same. It's when you start accessing its properties that you start actually observing something. I'm not sure why I started talking about this. Why did I start talking about this? Yeah, I can't remember. Anyways, so if a grocery was like complex, I would do like create grocery and do this thing, and I would create signals for what I need to observe and return that as normal getters. And then I would create methods for changing those things if you were supposed to be able to do that from the outside. Yeah, and then like in the privacy discussion, like if you had, let's just do it, create grocery. So ID string title. Let's say the title is changed, or name. The name is changed very, very often. The ID never changes. So you can say item.id, and then name is a signal of item name, and then we get the name, return name. So I think what makes like MobX so appealing with classes is that you don't have to do any of this. Like you can just say username equals Joe, and then in the like even if you use decorators, you can just say observable. Whoop, and then that isn't observable. Like it's a beautiful thing. But you could do the same with but the point is, if you do this, you will always be able to change it from the outside. And I'm not sure why I'm so hung up on privacy and what's private and public, but it is an important concept. And I'm probably taking it too far, but at least having the possibility to define what is actually public and what is actually considered private here. Can I trust that this thing only changes? So for example here, if you make username like this, and then you have get username, return this username, can I be perfectly sure that this dot username only changes new username string, new username? Can I be perfectly sure that this username only changes with this method? And doing so, we validate, maybe it's even freaking async, I don't know. Do I know that? Can I guarantee that? And in some code bases, that's not necessary. But it has to do with like the complexity, the number of people coming in, mix of junior and senior, and all of that stuff. And I think that's what's so frustrating when you're used to working in like this single person, you just get the stuff in there. You can spend like 15 minutes implementing something and it works, or you can spend like an hour implementing something and it works exactly the same, but it also has these boundaries and constraints to it so that it lives more prosperous in the future. And the question is it worth it? Was those 45 minutes actually worth it? And that's like, I don't know. And I think that's what I'm trying to do, is like, how can you prevent spending 45 extra minutes on making things, giving those boundaries and those constraints less, so that it's maybe 15 extra minutes instead of 45 kind of thing. Where the hell was I? Yeah, and then so here you would have like create grocery, and you would pass a name here. Yeah, and this will be like return type of create grocery. Sorry. Yeah. And this will be like name. Sorry. Let's just call it name. Goddamn naming. Oh, and then yeah, maybe you would create some ID here, math of random string. It would of course be something else than that. But then you might have something like um, you might have something that should update. Like it should subscribe. When you create it, you should subscribe. But how would you kind of do that? Would you, but this is the same with classes. It's like you have this constructor of some entity you shove into a list somewhere, and then, but you want to keep it up to date, but you don't want this public interface. So the name here, for example, should never be changed publicly from a component or even another store. It should just be updated from the subscription. But you created this isolated thing. But just like a class constructor, you would also do the same here. It's like, okay, pass a name, and then I would have, I guess it would kind of, yeah, and this is the thing I was reflecting on. It's like, what's the most efficient way of updating the insides of something? Like the insides needs to really subscribe to the outside. Is there a different way of doing that? Like the point is, you don't really want to create like a subscription inside this thing. Yeah, it's interesting. Like you could pass it the API, and then like in the API subscribe to grocery, and then you give it the ID of the grocery. But then you have like this subscription running inside this thing. Like I guess with a class, you would kind of do that, and you would dispose of the actual instance, and that would dispose of the subscription to the data. But I wonder if there's like a better way. I'm going. This wasn't really what I was gonna. I'm kind of rambling here. But this is the kind of stuff. This is how I think about state management. I'm like always diving into like I'm looking at something I can solve in the 15 minutes, but there's something wrong about that implementation. I'm taking shortcuts. I'm like making excuses that that'll be fine. All of that stuff. Yeah, the return type thing. Yeah, I I agree that with classes you kind of get the typing and the implementation in one go. That is true. You will kind of have to first define the type, and then, so I wouldn't typically do this. I would define like a use grocery type and then type it and make that the return type here. But it's kind of you're duplicating the implementation or definition of the grocery. So yeah. And also with classes, you can do instance of, which is also really great. What was I saying? Yeah, I wonder if there's like, if you can pass it like, you have like an inverse subscription. to pass it like just a subscribe callback. It's almost like you, how should I put it? Yeah, so this might look a little bit weird, but so I say subscribe, name, and then you would kind of get whatever item, and it would do some kind of yeah, no, that's really weird. Yeah, anyways, that's something else, like doing inverse subscriptions, because yeah, you kind of want these things to be very clean, and you want it to reflect like the correct privacy publicness of this entity. But then maybe there are certain things that should happen internally, and then the question is, how do you do that? Do you pass in all the dependencies that like is needed to keep things up to date internally, or can you do some kind of exposure of the internals instead, which I try to do here? Like you call subscribe and you send it the internals that you want it to do something with, keep up to date. But it's very much what's it called, indirection. It's very much like indirection. I guess what you could also do is like you could do API and disposer, and then you could say like disposer add API subscribe to grocery, and then the ID. So whenever you want to dispose of anything here, you kind of make that a dependency as well. Anyways, doesn't matter. But yeah, I haven't really thought about I thought about this article of using like this thing about using a function or a class. Like what's the up and downsides with the two approaches? I guess it depends on the complexity as well. Like I know that some stores, they would just completely blow up as a class with just a bunch of like private, public organizing. But yeah, I guess the point is that you can solve the same things. It's just a different way, and there's certain upsides to one approach as opposed to another one. Yeah, that was my point. Anyways, I'm actually not feeling that awesome. I just had to get this out. I'm gonna reflect some more on the implementation, and then we'll see what we do with this in the end. Implemented, and then I'm gonna hit the couch before I have to pick up the kids. Okay, I guess that's it. Yeah, what we can do is we can just publish the version and not document the API, and then yeah, I think I'm gonna do that. I'm just gonna publish it without changing the documentation, and then I'm gonna try it in the family Scrum app, because I definitely need some concept of this in that app, and then see how it works. Yeah, legend state. Yeah, I looked at it. I think it's very nice. I wonder how the hell they do the how the hell do they do this? So here they have this observer, but I saw they also have this. Where is it? They just call this function and then React suddenly is reactive. Where the hell was that? Everything is proxies. Oh. Yeah. Yeah, I was curious about. It's kind of like proxy state tree from Overmind, I guess, except that oh, even observer is a proxy. Where was this? Getting started. Yeah, enable React component. Oh, but they still use observer. Okay, sorry. I thought they didn't use it. Well, I guess that's... Yeah, here they don't use observer. But yeah, I think my biggest issue is... what's this store? Where's that coming from? Where's store coming from? Is it somewhere else? Is it like a global thing? Like there's no like structure to it. It's just the primitives. Yeah. Oh, that's interesting. Like it when you actually do get, you actually get the value. Yeah, because in proxy state tree, you keep getting proxies. Well, until you actually hit an actual value. But if it's like an array or an object, but you don't have that set and get thing, you just use it. But yeah. Yeah, all objects are plain. But it had a really big... Where's the... Didn't it have like a... React API? Yeah, it has such a huge API surface. Use selector, observer, use observe effect, use when ready, use observable reducer, using with use effect once, use mount, use unmount, use pause provider. Yeah, it's a really cool trade-off that you use proxies to like how should I put it? Use proxies to detect observation, but when you actually go and grab a value, you always get like the plain value. That's really nice. Yeah, that reminds me of Baobab, like the first state tree thing I was exposed to. It uses like cursors. Like this was way before proxies. It uses cursors. It was basically just an array of representing the path. So there you could also observe non-existing things. Where's the async stuff? Merge into observable. Yeah, you know what? This reminds me a lot about Baobab. It's just that they have proxies, so you don't need to do these explicit arrays to go and find things. You can just point to it, and then, but it also had like, you could think of each leaf, sorry, not each leaf, but each branch in the state is like a cursor, and you can listen to changes to it. You can get its value, you can set its value, and as we see here, you can also just observe it. Yeah, one thing I really got from this was the memo component. That was really interesting. I never thought about, but it's the same with MobX, right? You can use the observable component to just grab a value from your state store. And that's the same as memo. It's just that you use a callback inside observable as opposed to pointing a reference to the actual observable primitive. But that's the problem again. It's like, where's the memo thing? Yeah, so here, the count here, it's very interesting because I didn't think you would ever want anything observable inside a component. Like you can just use React's primitives, but this is an example where you would want it. It's when you have local observable and you consume that observable wrapped in like this component, memo component. Do they have a bubble transformer as well? Oh my god. Do they need that? But I think like what they're doing here is just like, let me show you this because I was playing around with this. So this thing, I don't think this is any different than observable. It's just that in observable, you would do store.count like this. While here, they have like this count thing here. It has a get and a set. It's kind of like solid. In solid, you do the same. You can pass like the actual. So in solid, you would just pass the count, but you actually have to call it to access its value and observe it. So if you squint a little bit, you could do the same here, right? Because it's just a function. So memo just calls this thing. It's a function. So, and solid does the same. So it's not actually, I thought it was the actual, like, you have to do get or something. So they actually transpile this into this. I think I've gotten traumatized by bubble transpiling after doing that class. What was it called? Classy UI. We did some crazy stuff there. Yeah, but I would argue that that's taking it too far. Like, why not just do this? Well, I guess you can't. Yeah, I guess you can't. Well, Yeah, but if you transpile it to this, it wouldn't work. Because if this represents the actual value and not like not actually accessing anything, you wouldn't be able to observe it. I don't, yeah, that's weird. Anyways, my point is that you can like think of the observable thing as a way to just observe something. So you can have this like, it's very interesting. Like you can even have this my component, like this very complicated like table thing. So you're not doing any observation in this component, but you have access to this store, use data store, and then you can create this crazy big table, and then you just go in exactly where you want to use the thing. You just go in and you say like, well, I guess this would be like you would map and all this stuff, but then you would say like item dot title, and that's also a way to define observation in components. It's not making the component itself observing, but you just use the component to extract the state from the stores, and then you have this granular observable pattern building a complex UI. Never thought about that until you showed me that table, and then I also saw the memo thing from Legend. Yeah, yeah. This isn't actually super like that's the icky thing here. It's like you have this, especially having this callback. Well, what's interesting is what you could do in impact if you actually expose the signal. Since the signal is just a function, you could do item. So given that title is the actual signal, you could actually do this because it's just a function, right? So observable, we just call the signal and observe it. So that's pretty cool. But the negative part of that is you have to actually expose the signal, which means that you would also be able to change it from the component, which might not be what you want to do. Which makes me think that like a signal could actually be like count, set count, and this is what Solid does. I think they have like create signal like this, so you would still have to call count to get the value, but they separate it. So you could expose the count like this. It's very interesting. Cause the point is, like the negative thing is that what the hell? It's my watch. It's thinking I'm talking to it. So you could expose it like this. So the count would be a function. And then, but if you wanted to, and then it would still be read only, right? Because you can only extract the value from it. And then you could do things like this very naturally. But if you wanted to be able to change it, you could do something like, well, just change count or whatever. You could just expose set count. Because that's one thing I've been thinking about is it's very nice to kind of do this get count, but it's a bit verbose, and also it's difficult in the component to know if it's an actual observable or not, because it looks like a plain value and you consume it like a plain value, but you don't really know if it's an observable. This is interesting. Yeah, exactly. So this is really how you could do it. Like you just export count. When you consume it in a component, to get the value, you actually have to like call it. And then you can use this very granular thing, just putting observable, and then you could even do just count. Let's imagine this is the, okay, let's finish it. Function my store. So you would do signal, and you would get count, set count, and then it would just return count, because there's something else internally that changes the count. Like maybe you have set interval, set count, current +1, something like that. So you only want to update it internally, and then externally you have use store, my store, and then you could still just grab count like this. But if you want to use it, if you actually want to like insert it, let's say put another TD here. So if I actually want to insert it there, I would have to call it normally. The good thing is that you know it's a signal. Like it literally looks different when it's an observable. And then you could do this very granular observation where you wrap it in an observable, if you really want to optimize it. And this is kind of like what Preact Signals does as well, but they actually completely hack React, so you don't even need this thing around it. But yeah, this is I wonder if this is a good thing. Maybe, yeah. This is worth evaluating, at least. Because then it would be much simpler. You didn't have to use these getters. You would naturally have read-only. But it's super easy to like just add set count here in this case. So it solves the verboseness of the current signal. It allows you to differentiate signals better in your components. What are plain values? What are actual signals? The only thing that's like a drawback is that you have to call them to get the value, but they are kind of a value in and of themselves, like it's a function. So if you do like, you might do this. This is a typical error. Like that's the drawback of it. Yeah, the thing I don't like about having big observable objects is that you're forced to allow people to change it as well. It's like if I had a complex object here, the count was a complex object. Like I wouldn't be able to control changing anything nested because I expose the full object, and then I'm forced that anyone outside can change any nested level of that object. So that's what I like about observables being actual values, as opposed to being this nested reactivity kind of thing. Is that you completely block where it can be changed. It can only be changed at top level. But if you allow nested reactivity, you can change it Yeah, I guess you could only expose a path, but like if it's an array of objects, for example, um, like with a signal now, it's being immutable, and you expose that array. You can try to change that array as much as you want, but it's like it won't affect like you can mutate it, of course, but it's like a use state. It won't trigger observation, like if you push to it or whatever, which is the same mindset as React. But if it's a nested observable object, you want to expose the array, but you don't want people to be able to change any items in that array. You want to control that adding of stuff to the array. Again, like you can very easily argue that, oh, taking it too far, you're creating artificial constraints, and definitely in some situation it is artificial constraints. But I just mean that like having that nested reactiveness, it what's it called? It creates tension with this need to control where change happens. Or I guess, or with legend, would you like return, have a getter, and then you will kind of list, and then you would do like list get kind of thing. So you would get like the full plain value, but it's like immutable. So if you try to add something to that array, like you can still like push to it, of course, but it wouldn't trigger observation. The only thing that triggers observation is list set, I guess. Well, how do they make changes in Legend? Like, how do, if you have a deeply nested thing, is it the same? Or is it like you could, oh yeah, so the benefit is like, okay, so you can return like the list like this, but if you want to change item, you could say like index change, and then you could go list index set change kind of thing. So you can, yeah, yeah, kind of like what I said with Bob. It's like you get these implicit cursors. You can just use JavaScript as a cursor to access something, and whenever you get something, it's like a locked value. Oh, okay. So you could do, so you wouldn't be, yeah, so this list.push is kind of like an observable API. Yeah, because that's the important thing. It's like with MobX, you don't have this kind of thing. It's all just a mutable object all the time. While here you rather go and you say, give me the current value at this point in the path. I remember someone created something similar, like what was it called? Something freezer? I can't remember. But yeah, this is definitely interesting. Yeah, exactly. But yeah, it's a lot to take in just to be able to manage deeply nested objects. I guess that's like a question. Like, do we really need that? Like in this case, yeah, yeah, exactly. Yeah, but it's like it's a very cool, interesting primitive. Because if you look at, so for example, here you could do like index set new change, for example. But if you use like immer, you can say list produce draft. It's more verbose. Oh, sorry, not draft, but draft. Index equals change. It is more verbose, but that's the thing. Like, I wonder where that balance is. It's like, okay, you can. There's like limits to this. It's almost like let's call it sign. So you can say sign change. Like a lot of state changes is like that, and then you have some state changes are like, okay, I need a current value to evaluate current plus change, for example. Or then you can say this it's current, it's a list, so now you want to do current and then add the change. But then you might do something like you want to change some index on title, for example, and then you can use immer for that. Because or you will have to do like a lot of spreading and stuff. But this is opt-in. That's the thing. It's like if you need to handle all that complexity. And I actually had immer internally. I just couldn't figure out how to handle promises. Now I can't remember why. Why was that a problem? Why was that a problem? Why did I remove immer? Because this is how it used to work at the point. It's like any signal, you can use the mutation API. Because it ran immer under the hood. Because that's also a way to do it. I can't quite remember. I had some issues with... Oh yeah, it was promises, because they could be... They could start out... Yeah, that was it. They were... Yeah, exactly. Yeah. Yeah, the async. Yeah, because it could start undefined, and then it was intended to be like a promise or undefined, but then it started as undefined. So when you then return a promise, there was no existing value to understand that, oh, this is... Wait, but is that a problem? If I return a promise, I could just check if it is a promise and then make it an observable promise. No, it was a draft here. Like this would be... I can't remember. That's worth revisiting, because it is kind of nice to say that you can choose. You can do mutation inside this update function if you want to do that, or you can treat it as immutable like you do here. That's it. It's interoperable in that sense. But yeah, there was something async. I can't remember exactly the exact thing, but it was related to not knowing that it was intended to be. Yeah, I can't remember. But yeah, I'll check the email, and I'm gonna merge this events thing. I'm just not gonna document it and try it out, and then we're gonna create a branch doing this. This is a big change, but as you say, like what we're talking about here is really how to structure what state is internal, what isn't, where these stores come from, and how much should they know, like the components know, and all this stuff. Yeah, yeah, exactly. But yeah, this one is super appealing for solving the not having the verbosity of defining these getters all the time, and make signal consumption more explicit in components, making it much easier to also use this observable thing. I find that exceptionally interesting. And we could even call it like not observable, we could call it like signal. Oh my god. Oh my god. Okay, I have like my intuition now, and unless like something dramatic pops into my head, this makes a lot more sense to me. Because even the first example, like you don't need the observer or anything. You can just do function, and you could say, like you could. I'm not sure if this is more appealing. Oh yeah, yeah. This one's interesting. Yeah, this is okay. Maybe it shouldn't be on the front page, but like this would have to be something like this. Yeah, maybe not. But the point is that it's possible. So that it actually only reconciles each part of the thingy. It would be nice to have like a... Yeah, it's interesting with that transpiler. Like if you name things like this, you just tell the transpiler that, oh, you should wrap this in a signal component. Oh my god. But that would be a problem here, right? Yeah, because it wouldn't make any sense here. Oh, good point. Yeah, very good point. You lose the typing. Yeah, so that's why I don't like build like translation, like with Svelte, for example. Svelte has become much better with the runes thing, but yeah, like that's when you do translation, like change the code from what it really is, you quickly get into typing issues. But the point is, it's possible to do. It is possible to do this. But yeah, and then let's just change the whole thing. So you would do set tick. So this is how it would look. Is ticking, set is ticking. And then you would just do tick is ticking. And then it will be tick set is ticking true. So this is how it would look instead. So you have the tick and the set tick. Oh, the set tick would be like this. So you have a tick and set tick is ticking, set is ticking, and you have the interval. You have tick is ticking, toggle. You check if it's ticking. Set tick, set is ticking. Cool. And then you can still just use observer, of course, but then you have yeah, and this should be called observer. And the reason is that you're observing. Like the other one's called observer, you have use observer, so it should be observer. Yeah. But anyway, so what if this isn't using that? So it would be tick. The only problem in that thing is that you can't then create conventions based on the signal value being able to get and set it. Oh, you can do that. But that, if you want that, which I want to argue is the thing you want the most resistance on, is that you can do get tick, return tick, and then set tick, return new value, set tick, new value. So from the outside now, if that's what you mean by two-way binding, now you can say, now you can say from the outside, you can say tick store. You can say tick store dot count and you'll get the value, or you can say tick store count equals 50, and then it works like that. Or you can do tick and set tick, of course. It depends on, sorry, set tick, tick, set tick. Yeah. Yeah, because, yeah, so I did in Observer. Well, what I realized is that the signature of this tick here. Oh, we don't know getter stuff. Yeah. But it's like, that's the thing that I see that is kind of the biggest, like, mindfuck for me when I look at a React component that shouldn't be mutating anything, and it mutates something. Then it's, I want to argue it's better to have tick set tick, because that is like the kind of logic you're writing components. But again, it's like, it's not because it's impractical to just be able to assign things. Yeah, I guess it's more of a principle. Yeah. Anyways, this was very, very interesting. Like you could just like doesn't Solid do this? Like you can create very easily create primitive over a signal, which is like state, and then call it state, and then you say tick 0 is ticking false, and then this state here, this is uses getters and setters. So you say state. The problem is you can't spread it. That's the problem. But you can expose it as state, for example, and then you can say state.tick to get the value, state.tick equals whatever to set the value. So it's basically just an object that converts signals into getters and setters. Well, this was super, super interesting. I'm gonna look at the legend link you sent me, Adam. Yeah, exactly. Exactly. So this is mutable signal or whatever. And then you it's really annoying that when spreading an object, it doesn't keep the getters and setters. It's very, very annoying. But you could, yeah, return state, or you could just return state, right? Because now you don't really need any methods on it. Because the methods are typically to change it, to change the state, but now you just change the state. Or it's possible to say, instead of a mutable signal, you could call it like store or something, and then you can say blah. And you can also have methods, right? So if it's a function, you don't make it a signal. It's just a function or a method. So you can do that. Yeah, it depends on what the store is. Because we already use the term store here. So this would be more... I don't know. Or you could do the thing you talked about, like new blah, and then you would do the make observable. It could work the same way. Like have a make observable that changes properties into signals under the hood, and then exposes getters and setters under the hood. So yeah, basically the same. Yeah, like Impact started out as these things being reactive contexts, like these functions. But it's kind of, yeah. But people have this idea of, yeah, what is a store? It's something more than state, at least. That was the important thing. It's more than state. It's not a reducer. It's more than state. But does that mean it should be like an API, or should that be included, or yeah. But cool. I'm gonna play around with this at least. I should really figure out how to publish tags. I keep publishing these changes on the main thing, but I think every time I push something or make a small change now, I think this is it. This is the final thing. And it's never the final thing. But like the important thing is that now we have this stream. Like we can really, like it took me a long time to get to this. And I have very strong arguments why this is better. But now after this stream, I understand why. Well, Solid maybe didn't have the same motivations for doing this, but I have a very strong sense of why this is preferable over this. It's just much simpler to control access to the signal and understand what's a signal and what's not a signal in a component. And it's simpler to use it with the observable component for granular reactivity. Yeah. Okay, cool. Thanks again, Adam. I have another hour on the couch before hell breaks loose. Funny. I was at a festival this weekend. I had a few friends visiting, and we talked about my stream. I just got an image from one of those friends who's not a programmer. He was watching my stream. Anyways, see you, Adam.